At a party, everyone shakes hands with everyone else. If 276 handshakes are exchanged, how many people are there at the party? So, if we have number of people and handshakes. So if there was one person, you'd have 0 handshakes. If there were 2 people, you'd have 1 handshake. If there were 3 people, you have, say, suppose you have A, B, C, 3 people. So you have A with B, A shakes hands with C, and also B shakes hands with C. So you'd have 3 handshakes. If you have 4 people, so we add 1 more people. So this person comes in and shakes hands. There were already existing 3 handshakes, and then plus D comes in and shakes hands with another 3 people. So that would be 3 plus 3, and that would be 6 handshakes. And then if you had 5 people, similarly you'd have 6, the existing 6, plus, so you'd have E, the 5th person coming in and shaking hand with another 4 people. Not 5, 4 people, because E is the 5th person. So plus 4, that's 10 people, or 10 handshakes. If you had 6 people, then it would be 10 plus, so you'd have another introduce, say you introduce the person F, and then what happens is F shakes hands with all of them, A, B, C, D, E. That's 5 people, so 10 plus 5, and that would be 15 handshakes, and it continues. So you see that this is a sequence, and that resembles the triangular number sequence. The difference being that it starts from at 0. So if we had n equals 1, the number of people, 1 would be 0. So n, if we had n and the term, if you write the term first, so the sequence of the term is n, or if you write the sequence of numbers is 0, then 1, then 3, then 6, then 10, then 15, and so on. And n, the number, the term would be 1. If there's 1 person, there's 0 handshake. So n is the person, or people, or persons, or whatever. So n is 1, and then 2, and 3, and 4, and 5, and 6. So now you see this, if you look at the sequence 0, 1, 3, 6, 10, 15, and if you do the difference is 1, then plus 1, then plus 2, plus 3, plus 4, and plus 5. So that's again the second level of difference. You 1, 1, 1, 1. So definitely it's a quadratic sequence. So we're going to do n square. N square would give us 1, 4, 9, and 16, and 25, and 36. Now if I'm going to do n square minus n, because I have to get 0 in the in the first number as. So if I did n square minus n, I would get 0. 4 minus 2 is 2, 9 minus 3 is 6, and that would give me 12. That'd give me 20, and then it give me 30. So then you see, if it's n square minus n, divided by 2, you'd get 0, you get 1, you get 3, you get 6, you get 10, and you get 15. See, we get back the original sequence. So here the sequence is for the nth term. Let's see. If I write the nth term of the sequence, I would get n square minus n out of 2, and that is n times n minus 1 out of 2, and that is the formula, so-called, for the number of handshakes, okay, where n is the number of people. So in our question, what is required is we have to find the number of people. There are 276 handshakes. So we have been given that n square minus n divided by 2 is 276. So I'm going to erase things out a bit so that I can work it out. So n square so we get n square minus n out of 2 is 276, or n square minus n equals 276 times 2, that's 2 and 1, so 14, 15, 5 and 1, you get 552. And so we can write n square minus n minus 552 equals 0. So we go to solve this, factorize it. So then if we have to factorize 552, we got to write it, find the factors. Start with 2, the easiest thing to start with. 2 times 2 is 4, 5, 15, 6, and then 2 again, 1, 2, 3, 6, and 1, 7, 8, and then 2 again, 6, 12, and 1, 13, 69, and 3 times 23. So we can say 2 times 2, 4 times 2, 8 times 3 is 24, and 23, 24 times 23, which is easy enough. N square minus 24n plus 23n minus 552 is 0. So n times n minus 24 and plus 23 times n minus 24 is 0. So we get 23 is 0. So if n minus 24 is 0, then n is 24. So there are 24 people at the party. It cannot be 23, of course, because it's negative. So there are 24 people at the party. And that's the answer.